And so today we're going to talk about what happens if and when intelligent life contacts us. So what would that be like? What should we say? Will we understand what they're saying? So to help us discuss this, our first guest is an anthropologist at York University, and she researches, amongst many other things, the evolution of intelligence, the colonisation of space. She's collaborated with the NASA Astrobiology Institute, the SETI Institute, and the 100-Year Starship Program. Please welcome Kathryn Denning. Our next guest is an astronomer at Columbia University, where he leads the Cool Worlds Lab. His research team is focused on discovering new planets and moons. Please welcome David Kipping. Also joining us, we have a philosopher from Barnard College, which is at Columbia University. She specialises in the philosophy of language and is the co-founder and co-organiser of FLIP, an annual conference that brings together philosophers and linguists from all over the world. Please welcome Karen Lewis. And our final guest is a biophysicist and head of the Laboratory of Integrative Neuroscience at Rockefeller University. Among many things, he studies the brains and communication skills of dolphins, which is kind of like an alien species. So he's an expert in deciphering alien languages. Please welcome Marcelo Magnasco. So David, catch us up to speed on the ways in which science is currently searching for intelligent life.
Sure. So probably the most famous program that's trying to look for evidence of extraterrestrial civilizations is called SETI, S-E-T-I. That's the Search for Extraterrestrial Intelligence. And traditionally, ever since Frank Drake first started this project, I think back in the 1960s, and with a famous project called Project Ozma, they started listening for radio signals, essentially hoping that somebody was transmitting in our direction. And that makes a lot of sense. Radio, which is a form of electromagnetic radiation, travels at the speed of light, so it's the fastest form of communication, and it's very cheap to produce and receive. So it kind of makes sense as a way to look. More recently, scientists, and I guess you might bunch me in with this group, have been thinking about other ways that you might be able to reveal the presence of extraterrestrial civilizations, one of which might be that they are not intending to tell us that they are here, they're not deliberately messaging us, but maybe we can still tell that they are there by virtue of their technology. So maybe they're building some giant alien engineering megastructure, and we might be able to see them in the act of building that, or maybe see the waste heat, for instance, from the giant machines they're using. So recently, both of those approaches have emerged as sort of the main avenues we're using.
And how do you see if someone's trying to build this weird alien structure, you know?
Yeah, that's a good question. It's almost like Arthur C. Clarke would say that such an advanced civilization would be indistinguishable from magic in a way. So how on earth can you look for something which could essentially be magic? And that's kind of what we kind of do. We look for things which are unnatural. So we think we understand how stars work. We think we understand how planets are built around planetary systems, and we look for stuff that is essentially just cannot be explained by any of the means. There's a very famous type of signal that we look for called a Dyson sphere. Maybe some of you have heard of that before. Freeman Dyson famously proposed that in the 1960s. And it's essentially saying, well, if energy growth continues at 2% per year, which is about how energy growth has been increasing over the last few decades, eventually, in like the year 3,500 or something, if you extrapolate it, we would need the energy from the entire sun. So how do you take the entire energy of a star? You build a shell around it. So we could maybe look for these giant shells built around stars. So you wouldn't see the starlight because it'd been blocked out, but you would see all of the waste heat that they were generating. So they can't get around the laws of thermodynamics, hopefully. Hopefully that's like, if they can beat thermodynamics, then basically we have no idea about how physics works at all. If they have to obey thermodynamics, then they should emit still some waste heat energy, and we look for the heat signature of stars, which do not appear in visible light, but appear in the infrared. And that would be a giveaway that somebody is extracting all of the light energy and doing something with it. So that's the type of signature that we can look for.
Any luck so far?
No, actually, but people have looked. So there's been about 100,000 nearby stars which have been surveyed for Dyson spheres, and about 100,000 galaxies which have been surveyed. And so far, there's no conclusive evidence of such a civilization, which in a way is kind of depressing. It means that these super advanced civilizations, if they exist, they don't do that very often. They don't use entire stellar outputs of stars. Yeah.
So we're not just as a species in terms of trying to find alien life. We're not just searching for it actively. We're also sending messages. We're broadcasting. Can you tell us a little bit about that?
Sure. So there's a program, there's an institute called the METI Institute, so Messaging Extraterrestrial Intelligence Institute. It's an outgrowth of a thread that was kind of present in SETI from the beginning, which was the idea that, well, one way to conduct the experiment, instead of just listening, go, yoo-hoo, and see if anybody answers. So there's a pretty major division, I would say, within the world of SETI on that subject. Some people are very firmly of the opinion that we should just listen, not broadcast. Others say, look, if there's anything out there to be worried about, chances are it knows we're here already, so we may as well say hello. Really quite different sets of opinions on that.
And where do you, Kathryn, where do you sit on this? And it's quite controversial, the debates that go down.
It is really quite controversial, and it's related to the question of risk. I should say, so as an anthropologist, rather than a person who is, an astronomer or somebody composing messages to transmit, I kind of study the debates. So I'm going to be annoyingly agnostic on this one as well and not commit. But so what I like to do instead is kind of look at this question of, well, for those who say that, in the public in particular, those who say that we should transmit, why are they saying that? What are their interests and what are their concerns? And for those who say we shouldn't transmit, what are their reasons? And then it all kind of spins out into this larger question about, okay, well, we all share this planet together. How do we decide these things? So it kind of spins quickly into a question of public-scientist relationships and different camps on Earth and all of that.
So if we do, say SETI does pick up a signal, maybe, David, what kind of signal are we likely to get?
Wow, that's a hard question to answer. It could be, classically the signal that people have been looking for is just a high-powered, narrow frequency, narrow bandpass range radio transmission. That's all it is. It's just like a pulse. That this star essentially appears very bright when you look at the specific wavelength of light, which corresponds to radio. Typically, the frequencies they look at is something called the waterhole. That is a frequency space in the universe which is naturally very quiet. So stars produce radio waves, quasars produce radio waves, galaxies emit plenty of radio. So you have to choose a frequency where the universe is not noisy. So there's this one particular bandpass called the waterhole that collectively SETI scientists have been sort of honing in on. And if you saw a very high-powered frequency that was way above the cosmic background noise, then you would say, okay, maybe there's something interesting here. But we've seen those. Actually, SETI at Home, which is this essentially the screensaver you can download and it processes through data that SETI have collected, sees about 72 signals like that per day on average. So there are 72 high-powered frequencies above the background noise, and most of them are just terrestrial interference. So this is just our own radio transmitters bouncing off the atmosphere, coming back down, or satellites in space, military satellites even. And it's very difficult to go through each one of those and figure out, is this genuinely something alien, or is this something just that was interfering? So one of the dreams for a long time of SETI has been, what if you could put a radio telescope on the back of the moon, on the far side of the moon? You wouldn't get any of the radio interference from the Earth whatsoever. So it'd be a very, very quiet region, and you just have the cosmos to deal with, and no human interference. So if we could build any kind of radio telescope to do SETI, that would probably be the radio telescope we would want, and then maybe we'd have a much clearer view of these things.
So say we did get a signal that it wasn't terrestrial interference. Karen, would we be able to interpret it? You're the linguist.
Okay, well, that's a great question. So I think there are a lot of challenges in interpreting a signal. So first of all, it's a matter of recognizing the signal as communicative in the first place, right? We don't want to try, maybe there's other ways to tell that it's evidence that there's intelligent life out there, right? If it's evidence that they have some sort of technology that they couldn't have if they weren't intelligent. That would be sort of a non-linguistic way of communicating that there is intelligent life. But if we think, okay, there's a signal and it's a piece of language and they want to communicate something, how do we even figure out that something's trying to be communicated in the first place? So if we think of what a language is a symbolic system, first of all, meaning however you encode it, whether there's sort of sounds that are coming out of my mouth right now, or a writing system, or a signing system, or Braille, or anything like that. Those are just, say the sounds are coming in my mouth, are just sounds, but they encode certain meaning. Other sounds don't encode meaning. And some are very complex and don't encode meaning. For example, think of a song or something like that. Music is made up of notes, but the notes don't pick out or refer to a particular thing in the world. So the first thing is just recognizing that there's a symbolic system here rather than something else that occurs in nature, something that's not supposed to have meaning at all. And second of all, the way language works, what makes it linguistic is that the speaker or the sender wanted to communicate something with that message. And we have to figure out what they wanted to communicate. If it's just sort of this random noise that came off into the universe, then we're trying to interpret something that's not interpretable. So the first thing is just trying to figure out whether this is something we should be interpreting in the first place. The next challenge is, of course, if we think it is something we should be interpreting, it is how to decode that. And I think there are challenges at all sorts of levels. One, we have to figure out just what the individual, so every language is made up of building blocks of meaning. So for example, if I just say something simple like, this chair is red and white, there's the words in the sentence are the building blocks of meaning. So we want to figure out something like chair refers to this sort of thing. And then there's the syntax, the grammar, how they form together. So when I say, this chair is red and white, I'm predicating the properties of being white and red of the chair. And we figure that out because we know the grammar of English. So whatever communication we have, if it's anything linguistic, it's going to have these building blocks of meaning and a way that they go together to communicate a message. And we're going to have to figure out both what those building blocks refer to and then how they click together to make a message. And that's even further more going to be complicated because chances are the aliens have very different things they want to talk about than we do. So they're not probably going to be talking about chairs or grandparents or people.
Internet bubbles.
Or internet bubbles or anything like that. So even sort of searching for what these building blocks could refer to, it's really hard because chances are it's going to be sort of outside of our concepts. And so even if somehow we decode that a certain word refers to something, we have a hypothesis of what sort of thing it refers to, we're not going to have any sense of sort of what role does that thing play in their society? Just as if we sent messages about chairs, even if somehow they could figure out the word chair referred to like this sort of thing, they have no idea what a chair is really or what role it plays in our society. So there's a sort of, even if you can somehow, and I doubt you can get through all those first layers, you're going to have, at the end, even if you somehow decode the message in a certain sense, you're not really going to understand the message.
If I just add something to that, you know, in terms of trying to translate these messages, it maybe seems to us right now like it's a long way off we'd be able to do that. So maybe the advanced civilization might anticipate that, and they might not actually attempt to send necessarily a specific message, but just to broadcast that they are, in the first case, just intelligent. So maybe you could just send the prime number sequence. So just a series of, you know, like Morse code almost, like beep, 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 and just send the series of prime numbers, and then at least we would know that that was not, there's no way that was a natural process. Nothing in nature just spits out prime numbers. So you might not be able to necessarily tell how to build some giant machine like in Contact, the 1997 film, but you might at least be able to say, hey, there's definitely somebody smart there, because that shouldn't happen naturally.
And David, so at the moment we're just kind of, the fun world we live in is we get a signal from far away. How far away are we talking here? Like what is the closest that intelligent life could currently be, based on how much we've scanned the universe so far?
So we do, I mean, one of the revolutions of the last 10, 20 years in astronomy has been the discovery of all of these planets in our solar neighborhood and beyond. The galaxy is about 100,000 light years across, to give you some sense of scale. And we have surveyed fairly well within about, I'd say, 2,000 light years of the sun, looking for planets. And we now know that most stars have planetary systems around them. And something like 10% of those stars, sun-like stars, have also Earth-like planets around them. So there is no shortage of Earth-like planets, of order of tens of billions likely in the Milky Way galaxy alone. The nearest example is probably our nearest star, actually. Proxima Centauri is the nearest star. You can't actually see it in the sky because it's too faint. It's a red dwarf star, much smaller than the sun. but it is the nearest star. It's just 4 light years away, and we now know that that has an Earth-like planet around it. Whether that planet truly is Earth-like, though, does it actually have a habitable biosphere around it? Does it have liquid water on it? We don't know. We just know there's a planet there that is essentially the same mass as the Earth, and it has, in principle, the right distance from the star that it could have liquid water.
Okay, so say that is where intelligent life is, a mere 4 light years away. So if they had sent us a signal, how long ago would they have sent that signal?
So if they're continuously broadcasting it, then we would be able to see it at any time. All we'd have to do is just look up, and we'd be able to see it.
But when did they make the call?
It would be 4 years. I mean, if it's 4 light years, then radio, just like light, travels at the speed of light. So it would take 4 years for backwards communication. So every text message we would send them, there would be, essentially we would send it. It would take 4 years to get there, then another 4 years to come back. So it'd be an 8-year turnaround time on communication for us to get a reply when we send a message back.
So that makes it very possible that we could have a little nice back and forth. But what happens if intelligent life is thousands of years away? Thousands of light years away?
Yeah, that's when it gets hard. And this is where METI, the messaging aspect is somewhat limited, because we've only been producing radio waves for, 100 years, would you say, something like this? So only 100 light-year bubble around the Earth actually would be aware of our radio transmissions. Everybody else in the Milky Way, up to 100,000 light years away, they might be able to tell there's a habitable planet here, but they wouldn't know that we were producing radio waves, because there hasn't been enough time for those radio waves to have reached them yet. So certainly when you look at the grander scale of the Milky Way, it's a very limited volume of the Milky Way that would certainly know that we were producing radio emissions.
So Kathryn, tell us, if we did get a signal that was from a planet thousands of light years away, how do we know that civilization is still existing?
We don't. So, I mean, that's one of the really difficult things. So let's assume a signal does come in. And I think everything that you've said in terms of the content, et cetera, is super important. And there are also facets of the way that search is conducted that means that a signal would be somewhat averaged out. And so a lot of the content would simply drop out. So first of all, I think it's important to realize that content, if it is there, would be difficult to decipher. And so anything that would conceivably tell us kind of the status of that civilization, we just really actually wouldn't have access to. So let's say that we do get a signal. It's only one. Observations would, of course, continue to see if there was a steady stream or something like that. But let's say that a signal comes in. We would really have a difficult time, I think, deciding whether that civilization or that society, let's use that word instead perhaps, is extant or extinct. And then that kind of changes the equation in some ways. There's been a couple of great science fiction stories, for example, about transmissions from an alien society, but basically they're just transmitting to say, goodbye, we're dying. And I mean, it's like, oh, how does that make us feel better? I don't know.
Is there any way that we can study societies on Earth to know, like, does society have a lifespan, and then we just build nuclear weapons and eventually kill ourselves?
Right, okay, great question. When Carl Sagan was writing about the lifetimes of technological civilizations, he was very concerned about our own. So, for example, when Cosmos came out in 1980, he was kind of fighting a battle on the side at the same time, a really, really important one regarding the effects of nuclear winter and the fact that a nuclear war isn't winnable. So he was very preoccupied at that time with this idea of our technological adolescence. How do we, as a global society, deal with the fact that we've achieved the capacity to destroy ourselves? And he was hoping that if we find a signal from the great beyond, that it would be proof that another civilization has survived this technological adolescence and has kind of come out the other side, and that maybe they could teach us something about how to be a sustainable, ideally peaceful civilization. But the thing is, if we're trying to understand civilizations out there from civilizations here, personally, my opinion as an anthropologist is that, well, we can speculate all we like about alien sociology, but it is speculation.
That's what we're here to do.
Well, that's what you're here to do. But I don't think that we can say anything all that meaningful. So there's kind of been every theory put forward about, okay, well, for a civilization to last a long time, they would have to be peaceful. Others say, no, they would just have to be hyper-aggressive and wipe everybody out. The problem is that we don't have the data to distinguish between those possibilities at this time. And so if we do if a detection is achieved, we won't actually know for sure what that means, and you'll have kind of every conceivable specialty on Earth saying, well, this means this, or this means this, but we won't actually know. So then that comes into these questions about, well, what do you want to believe, and how much do you want to believe it?
That kind of is a nice lead into let's take this alien adventure into phase 2. So say we don't just get a signal, but the alien spaceship arrives here and they come out. We're going to then also shift this conversation into a couple of gears. But Marcelo, let's spend some time talking about your research. You essentially talk to an alien species, if you will, dolphins.
Yes.
So after decades of research, because when these aliens come, we're going to want to communicate with them. After decades of research, how well can we communicate with dolphins?
Well, I would say not terribly well at all. In my particular case, I started studying dolphins 5 years ago, thinking that it would be soon that we would be able to have an understanding of at least whether or not they have something, a communication system approaching the complexity of human language. And 5 years later, I can tell you that we still don't have any idea. It's remarkably difficult to understand all of these issues the moment you step away from anthropomorphism, right? I mean, it's very easy to imagine that you can communicate with the great apes with which we have so much in common. But the moment you step into a completely different physical environment like water, okay, and you're trying to communicate with these other animals, okay, there's some extent to which we understand each other, as mammals all do with one another, and some extent to which we don't.
Can you tell me perhaps an example of where maybe you had your best communication with a dolphin after 5 years, where you really felt, yeah, we're getting somewhere here?
My best communication, okay. Yeah. So my best communication was once we were diving, we were pursuing a group, we had a group of teenage dolphins off of Belize. And they were just lounging around and, you know, horsing with one another. Some of them were sort of sleeping a siesta. It was 2 p.m. And they were all teenagers. If I recall correctly, they were all male. And they were just horsing with each other, you know, teenage style, okay? They were raking their teeth on each other and stuff. And there was a group of these 2 teenage dolphins that were going like that. Quintessential group of teenagers at the cafeteria that are always together going around and sneaking at everybody else. And we had been following them with the helicopter drones, okay? And at some point, batteries got out, and I decided, okay, I'm going to jump in the water with a GoPro and record from the water, because we had been on them for like an hour and a half, okay? And it was really fascinating, you know, all of this display of behaviors. And I get in the water, and there's these 2 teenagers that come around. And dolphins always, when you're in the water, you hear them well before you can see them. So,
what sound do they make?
So the sounds that dolphins make are a combination of 2 very different sounds. One of them is whistle-like at very high frequencies. They sound like... And a different sound is made by the echolocation clicks. That sounds like... And they can pulse that at extremely fast pace, okay? And when they do that, it sounds like a creaking door, maybe like this chair that's creaking, like kind of thing. And so these 2 guys, okay, were just lounging around, okay? They come around, they look at me, they echolocate on me, they turn, and the moment they turn, they start chattering. And I had the most distinct impression they were laughing at me. So that's the one time I understood what they were. I don't know exactly what they were saying about me, okay? Maybe they didn't like my fins. Maybe they thought that my figure in the water was unshapely and ungainly, okay? Or maybe they were commenting on the fact that having both eyes on the front of the face instead of the sides makes me look like a flounder or something. I don't know, okay, but
maybe that's what first contact will be like.
They were definitely laughing.
We actually have a video of your research. We have 2 videos. What if we play? This is one of dolphin surfing. Do you want to introduce it?
Yes, I think that the video So here we are on a boat, okay? You can see we have 2 GoPro balls, and you heard the sounds of the dolphins just before they came bow riding onto the front of the boat. Okay, so what you're seeing is a film made from the front of the boat. Dolphins from, you know, we know from the time of the Greek that they love to bow ride. They love to sort of surf on the pressure wave in the front of the boat. And this is one of the things we're trying to study. We're trying to get them to catch their communication in a very restricted activity, so that by restricting the nature of the activity, we can correlate what they're doing with their emissions, and we have a better chance at, because otherwise language is combinatorial, and there's no way you can explore all possible combinations of all possible things, okay? You're never going to be able to fill up a table with all the combinations, okay, just by observing. So what we do in these cases is we try to restrict the kind of behavior so that presumably there's a restricted set of words or verbs or, you know, whatever is it that they use, okay?
So they're unlikely to say, like, hey, let's go to the shore if you're in the middle of a...
Yeah, so if they are doing acrobatics, okay, and there's a systematic whistle that goes like every time that one is going to jump over the other one, we have at least proof that there's a correlation between a given vocal emission and a given physical act. Okay, we don't believe, you know, being next to the dolphins, we don't believe that there's any way that we can actually figure out the language if we cannot correlate behavior. That's why I don't think that you would learn a language, an alien language, just by listening to a transmission, okay? Because, I mean, you would have to find a recursive means of defining how to transmit the dictionary, okay? And what I mean by this, and how do you refer to physical objects, okay, if you don't have a common frame, okay?
So you talked about this a little bit, but what does your knowledge about how dolphins, how much we now understand about how dolphins speak, how much confidence does that give you that we'll understand what the aliens tell us? Doesn't look good, eh?
Well, I mean, we live with dolphins. We have known dolphins for 2,000 years, okay? You know, I mean, go to the Metropolitan Museum. You'll see them all over the Greek wing. You'll see, you know, they were sacred animals in Greece. So I don't know. It doesn't give me great confidence. If the moment that you step away from, you know, from certain commonalities. I mean, the interesting thing is that dolphins are still mammals, recognizably mammals, and they have a certain. They are able to recognize gestures and interact with us in ways that I would not anticipate necessarily would be the case with an alien species who might not even be made out of carbon, right? I mean, there might be some gas cloud with, you know, tendrils of stuff, you know.
Just a walking fart.
Yeah, something. Yeah. So who knows what they are? Okay. I mean, but you know, I mean, the moment you posit, you know, people with, you know, with limbs and stuff, okay, you're already positing a lot, right? And you know, it's interesting. Dolphins do not have arms, yet when, you know, trainers point at something, dolphins understand they're pointing at something and they orient to that. Okay. So even though they don't have means of pointing with hands. So there's all these commonalities that come from having a common neural substrate. We have brains of an essentially similar architecture. Okay, whatever engines in our brain that parse motion, that parse attitudes. Okay, they come from a common ground. Okay, and therefore when we interact together, we understand gestures. Dolphins are very gestural. Okay, there's a lot of non-vocal communication between them, in addition to the vocal communication, which is a lot. So I don't know. I mean, if you were together with an alien with which you cannot even understand physical gestures, okay, where do you start? I have no idea.
This takes us, what a beautiful segue, Karen, to the linguist. Where do we start? If you are our Amy Adams, sent to the aliens who've come forth, and they say, Karen, just sort it out. What are they saying?
Just sort it out.
You know, what are the steps? Walk me through. What would you do?
Well, that was I don't know how much we could do. So, I mean, in one sense, the stuff Marcelo brought up is very relevant because, so now in this scenario, I'm faced with the aliens, so I can get a little bit of sense of what do they resemble something like a mammal? So in one sense, chances are the aliens share no kind of similarity to our brain architecture, to our neural architecture. So I can't assume that they have the way they process the world is the same as the way I process the world or the way a dolphin processes the world, but I could at least maybe see if they have something that looks kind of like arms or legs, or sense whether they have vision. So the first thing I think I would do, and I should say I'm not a field linguist, so I don't, not like Amy Adams in the movie is a field linguist, I think, and she goes out into the field. These are people who actually go out and talk to people and try to figure out how foreign languages work. But I think the one thing I would do, and one thing that I don't think is highlighted very often, is just figure out what their physical senses are. Like, can they see? Do they see things in roughly the same way? Do they process vision in roughly the same way we do? Can they hear? At what frequency can they hear? What kind of sounds or gestures or other signals are they emitting? To get a sense for what kind of modality I'm even going to try to communicate with them. So to go back to Arrival, Amy Adams decides to start writing in English, which is not, I think, how I would start by writing on a whiteboard in English, because that might be one of the hardest ways for them to figure out what I was saying to them. And I think at some point, she goes, I don't know if I'm remembering this right, but she tries to teach them one of the first things is something like her name and then that she's walking, which is a really weird thing to start with. Maybe not the name, but you have to assume that they have a practice of naming too, and that they're going to understand what you're doing. And then these animals don't walk at all that she's dealing with in their movie. They're kind of cephalopods that move through this weird kind of substance like this. And so
They did walk, though.
They kind of walk. They kind of like shuffle.
Yeah.
So I'm not sure. So this is just to highlight that it's not clear what kind of concepts they would have. So it's not clear where you can start. But I think starting by seeing how they respond to the environment, just taking data on sort of what sounds or images or other kind of data they emit under what certain stimuli would be the.
Can you give me an example?
Can I give you an example? Sure. So I mean, just very simply, the idea would be, suppose I take an object, like I have like a red square, and I put it in front of them, and then I see if they say anything, or if they pick it up, what do they say? And then I can maybe vary that, like try a red ball, and then if something's in common, I mean, this is a very toy example because it would take a lot more data than this, but if they say something in common, maybe they're picking up on red. And then pick at something else that's the same shape as the cube, but a different color. And if there's something in common with what they admitted with the first thing, then maybe they were talking about the shape. So maybe this gives me some indication of what their language is like, and some indication are they picking up on color or shape or something like that.
Tell me about this idea that David has suggested with using maths. Prime numbers was the example. What do you think about this idea of what if we just started,
Yeah. So I think there's two things to think about with using math. So some people talk about, so his idea of using just a sequence of prime numbers, I think for that the question is sort of what do you want to do in communicating? Now if you want to just indicate that there's intelligent life here, then I think that might be a good way to go, right? Because if it's true that prime numbers don't occur in nature, you might be showing, well, here's some sort of signal that there's something non-natural here, something that had to be produced by an intelligent species. But
they're not going to be particularly impressed, are they?
Yeah.
They're not going to be like, whoa, they sent me a prime number, these humans.
Yeah, but if you want to do more than just say, hey, we're here, if you want to communicate, then you might have to go beyond math or beyond at least simple sequences of things like prime numbers. The second thing I think to keep in mind is some people talk about math as this universal language. But math itself is not a language. When we're talking about mathematical concepts, they still have to be encoded in some sort of symbolic system. That is, there's still going to be these units of meaning that are somewhat arbitrary that match onto the concepts. They don't have to be completely arbitrary, like in the sense of representing numbers, we can do 1 beat for 1, 2 beeps for 2, or something like that. But once we get beyond the numbers, if we want to encode addition, let's say, we encode it in our mathematical system by writing a little plus, but that's just one of the many ways we could arbitrarily encode addition or something like that. And they're still going to have to decode it. Or if they send a message to us about math, we're still going to have to decode it. And there's still going to be a syntax. There's, in our writing system for math, if we want to write 2 plus 2 is 4, first we write the 2, then we put the plus in the middle, then we put the 2 equals and 4. But there's systems like in computer programming languages where you might put the plus out front. Right? That's just a very simple system. And so there's still a syntax, there's still a grammar to math, and there's still an encoding, and someone's still going to have to figure that out. So I think it solves some of the challenges because I think there is good reason to think that any especially if the aliens have arrived on Earth, that they have enough understanding of mathematics to have built the spaceship and come here. And so we've solved some of the systems because maybe that's the one place where we share some concepts. We could solve some of the problems, rather, because that's one place where we share some concepts, but we haven't solved sort of many of the layers.
If I could just add to that a little bit, it actually touches on the METI as well, the messaging, because when the first messages were being designed, and Carl Sagan helped design some of the messages, one example is the Arecibo message that was very famously broadcast from in Puerto Rico, this giant Arecibo array. And another was these gold discs and carvings that were put on the Voyager spacecraft that Carl Sagan also had a hand in putting on. And on them, there is a little bit of maths, and they're often designed to try to teach you the syntax. So give several examples of 2, 2, 4, and it doesn't really matter what the symbols are. If they see enough examples, hopefully they can figure out what the syntax is. And then also just diagrams. This is what a human being looks like. This is the local pulsars around us, so you can locate exactly where the Earth is, for instance. That was on these original messages. The downside of that is, though, with a gold disc, it's kind of, you just hold it and you can kind of just look at it, and there's no way to decode it. You're just sort of really studying the content. The Arecibo message was a 23 by 73 pixel image. But if they didn't know it was that way around, if they did 73 by 23 instead, you just get garbage. So you have to know the key to construct the image. So a visual representation seems appealing because you could teach them all of maths and what a human being looks like. But if they don't know the correct key, they might unlock it and it looks like garbage to us, and they're like, oh, that looks like something I recognize, and they might think that's the correct signal. But if they don't know in advance what the key is, then they're kind of stuck.
May I add that I think that it's a huge assumption to think that the aliens think that 1 + 1 is the beginning of math. Okay, that we are based on beings at a certain less scale, energy scale. We have fingers, we count on our fingers. We start with counting, okay? If you had an intelligence who operated in the quantum mechanical regime, quantum computing is fundamentally distinct from arithmetic computing, and they might not have the notion of objects as, the counting objects as their primary method of counting. So it might not be that an alien civilization considers 1, 2, 3, 5, 7, the 11 to be a proof of intelligence in any way. Okay, I mean, so even at this level, if you do not put a bound on which kind of, life you're dealing with, okay, then you cannot conceivably put a bound on how you're going to communicate with them.
I think you're right, but in a way you kind of have no choice but to put a bound, because otherwise,
yes,
there's an
you
infinite range of
they have to be
possibilities.
sufficiently similar to us.
So when you take a baby and you put them in any culture, they can learn the language. So should we just give the aliens a baby and then wait for it to grow up?
Let's check with an ethics
Catherine,
board.
discuss.
Child
We'd have a
services
hard
might be
time.
called on
Yeah.
And then
Hard time
follow-up
getting
question,
one passed.
could we just make a baby live amongst the dolphins, and then could we then get it to decipher what's going on?
Yeah. That's gonna work. That's gonna work.
So if we were to discover and contact intelligent life, it would be, one of the biggest moments of human history, if not the biggest. How do you think it would go over on Earth? Kathryn, I mean, what does happen next?
It depends. As an anthropologist, that's the only answer I can give. So it depends on what's happening in the world at that time. It depends on who you are.
Say right now. Tomorrow.
Tomorrow. What time?
9:30.
Early, 9:30?
Yeah, commute. Everyone's coming to work.
Okay, all right. How does the detection unfold? Twitter, okay. All right, so we got Twitter, we got 9:30. Who's it coming from?
The aliens.
Oh, it's coming straight from the aliens?
They're tweeting.
Do you guys want to participate in this hypothetical?
Awesome. Okay, now this we can have fun with. Okay, so the aliens have hacked Twitter.
Say it comes from the SETI Twitter account.
Okay,
Guys, we
saying
found
it's
something.
coming from one of the SETI Twitter accounts.
Yeah.
Okay, found it. Hi.
Yeah.
Okay,
little alien emoji.
right. Yeah. Okay. Right. So I think, here's the really interesting thing then. I think we're going to have a whole lot of human questions at that moment, right? So, maybe in the Q&A we can talk about what your questions would be at that moment. Like, what would you want to know? And I think, so there are a lot of really important things that would affect the reception of that signal. First of all, so let's imagine you're in North Korea and you've just heard this news from the US. What's your reaction? Other places in the world similarly. I mean, so would they accept, say, the authority of a scientist coming out of the US about, we really did find this thing? Given all the atmosphere around fake news and all that, I think there could be a lot of distrust, a lot of confusion, and a lot of uncertainty about who to trust. Let's say, I should specify here I'm Canadian. So let's say that the President of the United States decides to get in on the Twitter theme. So what?
Can't imagine that.
I know it's really unheard of, but like, what happens then? So does that contribute or detract, or it certainly messes things up creatively and interesting. And then there's the effects on the stock market. So people are kind of going, okay, what do we want to invest in? What do we want to divest from? Weapons, pharmaceuticals, prepping equipment. You can kind of easily imagine things like that. From the surveys that have been done on people's anticipations about extraterrestrial life, et cetera, some people are very anxious about it. Some people are very excited. Some people are like, beam me up, please. Others are like, no, I'm heading for the hills. So there could be a lot of different responses. And I think when I said, it depends also on what else is happening in the world. So if you're in a war zone already, if you're recently recovering from a war, if you've been traumatized in any way, this might really be the last thing that you want. If, on the other hand, you're just kind of very hopeful about what aliens might provide to human civilization, So, and there's also, from the surveys that have been done, there's a real kind of difference in degree of likelihood to believe. So there are regional differences, there are political differences, there are religious differences.
So who is more likely to believe what?
Well, and there's also questions about governmental authority and how people are more likely to believe in conspiracies, et cetera. So, I mean, there's differences between the West, the Midwest, the Northeast. There's male-female differences.
So who is more, so if there was a sign, who's like, the West or the East, like Californians versus New York, like, a little more.
I don't have the statistics right in my head because I wasn't the one that did the research. I think the point I'm just trying to make is that there is variation, and then that's going to affect kind of the overall reception. And then there's the question of, oh my goodness, well, what do we do? Because again, some people are very much in favor of sending a reply, and whether or not there's a global response that says, yes, let's write a message together and send it, somebody's going to. It's just going to happen. And then other people will be upset because they'll be like, I wish you'd just stayed quiet. And I think there could be scope for quite a lot of friction here. So the research that has been done on potential receptions to contact, it indicates a lot of instability. So I think one frame that SETI is understood within is just the idea that this would just be a continuation of all the research that has indicated that, well, we're not the center of the universe. So, we are just on a planet orbiting a sun among, many planets orbiting many suns. So that's been the huge contribution of astronomy over the last few centuries. It's been kind of decentering us, right? So that's one frame of understanding. But another is that, okay, well, these are other sentient beings. It's not just about our place. So then it all becomes about, well, what's that relationship going to be like? And how does that play into existing relationships here on Earth?
So, Marcelo, as someone who doesn't research this specific question directly, I mean, as a regular civilian but rational thinker, how would you feel?
Well, first of all, the most important thing is to know what kind of a signal we got. Yeah. Namely, if we got a signal from 2,000 light years away, okay, and these guys might not even be alive by now, it's very different than if you have a huge UFO, right over Central Park, okay? And,
yeah.
Right? So it obviously is a very different thing. In every single science fiction movie in which you have arrival of a hostile civilization, their UFOs are creepy. And whenever a friendly civilization comes, okay, the UFOs are cute. And and this is absurd, okay? Namely, there is no basis for thinking that we have a common aesthetic code, or that they would make any devices for transport, okay, according to our preferences is what is creepy or cute, right? Yeah. So all of a sudden comes this huge, enormously, creepy, UFO, and the guys are just, hey, hello, how are you, right? We don't know. Okay, I mean, there's, it's. We're really making all this thing up. Right?
There is actually almost a dress rehearsal of exactly what happened, though. A real example of this, which was the War of the Worlds broadcast in 1938. So that was a radio broadcast by Columbia Broadcasting Systems, and it's H.G. Wells' famous story that was made for radio, with the narrator, and it's done in a way that's like a news report if you listen to it. So people who just tuned in halfway through really thought it was an invasion, because there's like journalists on the scene during the moments when the aliens come out of the spaceship and stuff and start lasering everyone. So people were pretty panicked about it, and actually the telephone switchboard at the broadcaster got completely inundated with phone calls of concerned people. Police arrived at the radio station, and then there was journalistic reports the next day, and the New York Times had a headline about people confused, thinking the radio broadcast was real. So that was kind of like one of the few insights, although that wasn't really contact, that was a hostile invasion. So it's not surprising people panicked in that case, but it's one of the few historical instances where we have some insight as to how people might react, thinking it was a genuine event.
That's an interesting one too, because it kind of spun out into this whole new kind of distrust in the popular media, because the feeling was, well, if you could pull that on us, that's not cool. And so it actually started an interesting trend. But there's also been a lot of reanalysis of that one about, just exactly how much people were panicked, et cetera. But there have also been echoes. So there was a case, for example, a few years later in Quito, where the same thing was rebroadcast. Unfortunately, it went really, really badly in that particular case. And it was because they'd only recently come out of a war themselves, horrific invasions, etc. And the people who had fought defensively in that war didn't think this was funny. They torched the radio station. People died. And that one doesn't get cited, but that's something that I think of, for example, when I kind of think about, potential negative consequences.
And just a question for everyone on the panel, what do you think of this idea that if we know there's alien life out there, we'll all forget our differences and save racism for the aliens?
That's the usual kind of hopeful take on things. It's part of the kind of the Sagan-esque justification for shifting our frame of reference, and for and when I say justification, that sounds a little bit harsh. It's the kind of the cultural frame of reference that says, by having that confirmation that again, another society has survived their technological adolescence, that it could bring out the best in us somehow. From what I understand of world history, I don't really buy it. I think it has just as much potential to bring out divisions, especially if there is actually some degree of actual contact. I don't think it would be surprising to see jockeying, because this is something we've seen in real contact episodes on Earth. It's not just one side and the other side. It's like, how can I make this work to my advantage? And so it's people trying to build alliances, and then it becomes my enemy's enemy is my friend. It gets very complicated. It doesn't just kind of come down into oh, we're all suddenly unified as in humanity, holding hands, singing Kumbaya, etc. I think it's likely to be more complicated than that, and not necessarily also adorable.
I was going to jump in. I agree. I think it's very unlikely that even in the presence of a new other that's perhaps way more other than any of the ones we have on Earth, like the alien being the new other, that it's unlikely we're going to overcome thousands of years of racism and xenophobia and notice our commonalities in those moments, rather than perhaps those differences being highlighted by the fact that we now have to deal with some sort of imminent, potentially harmful event. Maybe, I mean, this is really highly speculative. Maybe if the aliens remained interacting with people of Earth over a long, long period of time, they would be so different that there would be more alliances between Earth people, and they would be the new other. But I don't think that would be anything like an instant reaction, and I don't even think that would necessarily be a likely thing to happen over a long period of time.
David?
Well, I just often say to my class that you could travel for 1 billion light years in any direction in the universe, and you will not meet another human being. That every human being on this planet is extremely rare and precious in the context of the entire universe. Even though it seems like there's a lot of us, there's like, maybe 8 billion or 7 billion people right now on the planet. If you divide that by the size of the universe, there's very, very few of us. So I think as just even forgetting aliens exist or not, if you just take a cosmic perspective, that you would maybe think of your fellow human being as being a bit more worthy of your kindness and compassion than if you just had this us versus them attitude. How's it going to react when the aliens come? So I think the better approach is just to think about the vast scale of the universe rather than to worry about interspecies relations.
So if we haven't had that feeling of warmth already, then forget it. When is that the bottom line? Marcelo?
It's a tough one, right? Basically everybody goes, oh, when they look at dolphins. So maybe there's hope for aliens unifying us, but of course it depends in which guys they come, right? I mean, if they're hostiles, okay, there's immediately an exacerbation of all your divisions. So and so is collaborating with them, okay? Or they are gonna, there's gonna be treason or this or that, and that's gonna be inflamed in no time flat, right? So I don't know.
David, I mean, in the popular imagination, and even in sort of scientific thinking now, the pendulum has sort of switched just with the numbers game, that there is probably intelligent life out there somewhere. Whether we would ever communicate with it, we don't know. But like, it seems like the scientific pendulum has switched. It's probably out there. What if it is not out there? Like, what if we are alone? How does that change your thinking?
Yeah. So I'll just first say that I personally challenge the idea that the numbers game proves that therefore there's intelligence everywhere. I mean, this is kind of going back to the very beginning of the show, but there's no reason why the probability couldn't be very, very tiny. People often cite the fact that life emerged early on the Earth as proof of the fact that therefore life must start very easily. But it took 4 billion years of evolution to get to this point. In 1 billion years, the sun will make the Earth uninhabitable. So it kind of had to have started pretty soon, else we wouldn't be here to observe it. So it's a bit of a circular argument. So you really can't take the early start to the life on Earth as meaning anything. So to answer your question more directly, if it does indeed turn out that life is incredibly precious, then I guess that just really re-emphasizes my original point about how precious human beings are on this Earth, that there is obviously a set of circumstances which happened here in the solar system which makes it extremely special in a cosmic perspective. I would still be pretty skeptical that forever, throughout the entire history of the universe, there will be no life elsewhere in the universe. I leave intelligence aside and just say life elsewhere. And the reason is because in 10 trillion years, there will still be some stars which are burning hydrogen and still will have planets around them in the right distance for life in 10 trillion years. And the universe is only about 10 billion years old. So we're at the very beginning of the story of the universe still. And actually, most stars are these small M dwarfs which will still be burning into the far distant future. So I think maybe we're just, if we happen to be alone right now, it probably means we're just one of the first, rather than we're necessarily going to be the only ones that will ever exist. I'd probably take that perspective a little bit more. I think the idea that the fact we're alone right now proves that's it, we're done, we're the only ones that will ever be, I wouldn't quite buy that argument. So there's plenty of time left in the age of the universe for other things to happen.
We're going to open it up to everyone in the audience now. If you have questions, just hold out until we have a microphone on your mouth.
With respect to David's point about being early, do we think maybe AI could help us find them better than humans?
Yeah, sure. I think certainly machine learning techniques, of which artificial intelligence is sort of an extension of that, are already being used to help the search for extraterrestrial intelligence. So this algorithm that you can download in your computer called SETI at Home actually basically does that. It essentially uses some machine learning algorithms to scan through these huge libraries of data which have been collected, all the radio transmissions, and see if there's anything that looks like a significant pattern amongst that data. And those algorithms are improving all the time. And as we get closer and closer towards these very sophisticated AIs, I have no doubt that it would greatly help us sift through more and more data. So yeah, I think you're exactly right, that as our software more generally improves, we can expect to be able to do a more complete job of surveying the sky for advanced civilizations.
So you tossed out this idea in a haphazard way of giving a baby to an alien. And I'm actually curious if there might be a sort of more realistic implementation of using the natural resources that we have in our own children to bridge languages with dolphins or aliens or other human civilizations. Is that something that's been done, or that could actually be, you know, labor laws notwithstanding, used?
I guess I can take that one. So there has been a large number of what's called cross-fostering experiments done, and I'm nowhere familiar with all of that literature. But what typically happens is that unless you're actually giving a human child to another human, okay, and let's remember that there really are, genetically speaking, no races, okay, so that it's just a member of the same species, okay? That's not cross-fostering, okay? But for instance, if you raise a canary among zebra finches, the canary will try to learn to sing like a zebra finch that has a very different song, and at some level it will acquire many of the elements of their song, and it will fail to acquire others. Because at some level, you know, there's a breakdown in how much their hardware can imitate the, you know, canaries sing something that, if you slow it down, is sort of like Gregorian chant, while zebra finches are rappers. And there's simply no way in which a canary can sing zebra finch song. They just are ill-equipped. Okay, so cross-fostering experiments really run afoul of, you know, differences in hardware that are insurmountable, right? Like in this particular case, okay, you can't have a human baby breathing underwater. So you cannot give it to dolphins, okay? I mean, it's part of the, it's part of the chic of the joke, right? But you really cannot. There's a limitation to how much you can cross-foster, okay, across species that are actually physically distinct. So dolphins, for instance, they communicate in a ultrasound range, okay, some of which we can hear, most of which we cannot. They see in a visual range, okay, that they don't see red, they don't see orange. Their vision starts in the green, okay, and it goes all the way to violet and maybe beyond, and therefore they see naturally in a different spectral range, just like they speak and hear in a different spectral range. There's nothing innate in a human baby that if a human baby is raised with a species that speaks at a different frequency range, they wouldn't be able to hear that. They just are ill-equipped in the same way that we will never, no matter who raises us, we will never see ultraviolet or infrared. It's just the way our sensors are encoded. So there's intrinsic limitations of how much you can do of this, and because the physical environment determines so much how we perceive the world, okay? Our senses are exquisitely adjusted, okay, to our sensory environment, okay, and to our evolutionary history. So I don't think there's any way to actually do anything of the sort.
Can I jump in?
Yeah,
oh, so you can.
No, yeah.
I just want to jump in on that and say there's another limitation on this kind of thing is that a lot of linguists think that humans have something called universal grammar, which is something like something to do with like an innate language faculty. Even though languages can be very different, all human languages have some commonalities in their grammar. And in a sense, there's some part of us, some part of the hardwiring of our brain that we're the kind of creatures that are just born knowing how to pick up human languages. And then we're immersed in a particular language, and that's why, you know, babies can learn whatever language that they're born into. But there's no real reason to think that an alien language, maybe dolphin language, because at least we have some commonality. I'm not going to speak on dolphins, but there's no reason to think that an alien language is going to share in that universal grammar. So even if we could take one of our human babies, all the other concerns notwithstanding, and send them to live with the aliens, it's not clear that we have the right kind of, a human baby would have the right kind of brain to even pick up the alien language.
Yes.
I was just going to say, following on, I think one of the things that children have and are encouraged in is curiosity. And I think that's the first place that any kind of communication challenge starts. And the reason I'm just thinking about this is because of laboratory mice, so one of the most studied creatures on the planet, right? And it took decades for somebody to notice that they sing. I know, right? So Google white mice singing. It's going to be really interesting. But it's because, of course, they're outside of our frequency range, so nobody could hear them, and nobody noticed that when the mice are doing this, it's like, and they have their little mouths open, they're singing. So, but it took somebody kind of looking differently to miking them and then putting it through a computer to realize, oh my goodness. And now, of course, there's this lovely study on, what are mice singing and when are they singing to each other and what does it all mean? But it took that kind of spark, that moment of curiosity. And I think, that's something that we can all kind of encourage in ourselves as we, address our many different communication challenges, aliens or not.
And with that, we've run out of time. Thank you very much. Thanks, everyone. And please thank our guests.